Welcome back to The Explainer. All right, today we're going to tackle a question that, let's be honest, trips up pretty much everyone. What is the real difference between memory and storage on your computer?
Think about it. You've been hammering away at a document for an hour. You finally hit save, and poof, it just vanishes into the machine. But where does it actually go? And how is that place different from the space it was using while you were busy typing? Let's solve that little mystery. You know, the easiest way to wrap your head around this is to think of your computer as having two different kinds of minds. It's got a fast-acting, short-term brain for what it's doing right now, and then it has a long-term archive for everything it needs to remember.
So at its most basic level, your computer divides its thinking into these two camps. Everything it's actively working on right now happens in what we call primary memory. Then, when it's time to put something away for the long haul, that data gets moved over to secondary storage, which can be inside your machine or, an external drive.
Okay, so here's the absolute key takeaway. Memory? That's your computer's temporary workspace, like a desk. It's super fast, but the second you turn off the power, whoosh, it's all gone. Storage, on the other hand, that's your permanent filing cabinet. It's slower to get stuff out of, but it holds onto your files, well, pretty much forever.
All right, so let's dig into that workspace first. That fast, temporary part of the brain we call primary memory.
This is where all the action happens. When you open an app, load a website, edit a photo, all that active data gets loaded into this primary memory so the main brain of the computer, the CPU, can get to it in a flash.
Now, it gets a little more interesting because even this workspace has two very different parts doing specific jobs. You've got RAM, which is kind of like a scratch pad for all your open tasks, and then you've got ROM, which is more like a permanent, non-negotiable instruction manual.
And here's the difference, plain and simple. RAM is volatile, a fancy word for temporary. Power goes off, it's wiped clean. It's where your open apps are living and breathing. ROM, that's non-volatile. It's permanent. You can't change it. It just holds the super basic instructions your computer needs just to wake up, the BIOS.
And this is exactly why people say adding more RAM makes your computer faster. It's literally like upgrading from a tiny little desk to a massive workbench. You can spread out more projects, run more apps at once, and things don't get all slow and clunky.
And if you want to get super nerdy about it, the RAM in your computer is usually called DRAM. But there's also this crazy fast, super expensive version called SRAM that's used for something called cache memory right next to the processor. For our purposes, though, just think of them all as part of that fast, temporary workspace.
Okay, so we've talked about the desk. Now let's move on to the permanent filing cabinet, secondary storage.
Right. So when you go to buy a new laptop and you see 1 terabyte of storage, this is what they're talking about. It's the long-term home for everything. Your operating system, all your apps, every photo, every document you've ever saved. It's all safe and sound even when you unplug it.
For decades, the go-to for this was the hard disk drive, the HDD. I mean, think of it like a miniature, incredibly fast record player. It has a physical arm that zips back and forth, reading and writing your data onto these spinning magnetic disks.
But today, the new kid on the block is the solid-state drive, or SSD, and it's a total game changer. There are 0 moving parts. It's basically just a giant, really sophisticated USB stick that's built right into your machine, storing everything on microchips.
So what's the big deal? Well, with no moving parts, an SSD is just ridiculously faster and way more reliable. You know that feeling when a new laptop boots up in like 5 seconds? Yeah, you can thank the SSD for that.
Okay, so we've got our super fast desk, the RAM, and our big, permanent filing cabinet, the SSD. So what happens when you've got, 50 browser tabs open and your desk gets completely full? What then?
Well, logically, if there's no more space on the desk, you can't start a new project, right? For a computer, that would mean a total system crash. Everything would just freeze up and die.
But computers have this really clever trick up their sleeve called virtual memory. When that desk, your RAM, gets totally full, the operating system is smart enough to find the pile of work you haven't looked at in a while and temporarily shoves it over into the filing cabinet, the SSD. That frees up some precious desk space for what you're trying to do right now.
There's just one catch. Remember how we said the filing cabinet is way slower than the desk? Well, if the computer has to keep running back and forth, swapping stuff between the fast RAM and the slow storage, you get something called disk thrashing. And that is that awful, laggy feeling you get when your computer is overloaded and just grinds to a halt.
All right,
So far, everything we've talked about has been happening right inside your device. But these days, our filing cabinet, well, it extends way beyond that. Let's talk about the cloud.
When you boil it all down, cloud storage is just a fancy way of saying you're renting space in someone else's massive filing cabinet. Seriously, instead of saving a file to your laptop's own storage, you're sending it over the internet to a giant server in a data center that could be hundreds of miles away.
And it's a really clear trade-off, right? On one side, the benefits are awesome. You can get to your files from anywhere on any device, and it's a great backup if your computer dies. But the flip side is you're now totally dependent on your internet connection, there can be subscription costs, and the really big one, security.
And we're not just talking hypothetically here. These risks are absolutely real. When you give your data to someone else, you're not in control anymore. We've seen it time and time again, from huge security flaws that forced servers to reboot, to hacked celebrity accounts, to massive data breaches that exposed millions of voter records. Convenience definitely has a price.
So, think about where we are now. Our data lives everywhere at once, from the fleeting temporary scratch pad of RAM inside our machine, all the way to this massive global network of storage servers. It's made our digital lives incredibly powerful, for sure, but it leaves us with this big lingering question. In spreading everything out like this, have we actually made our data stronger, or have we just made it more vulnerable than ever before?